Hello, everybody, and welcome to this talk about building a European cloud. So I've been talking at this wonderful conference for several years, I think 2009 and 2011, so it's a pleasure to be here. Every year there are more people, and it's always fun to be here. So as I said, this talk is about building a European cloud, so we will actually go and look at the European as well as the cloud part. So first of all, why do we need a European cloud? Or do we need a European cloud at all? And if, do we then also need a Hungarian cloud? Or maybe a Budapest cloud? Or maybe we all need our own clouds? The answer is pretty simple. I don't think so. Why? I think, well, cloud is a term that has been heavily overdone, but what is it about? It's about sharing. Why is cloud about sharing? Having a look at the past, or at least as I perceived it, the first real cloud I perceived was Amazon, with Amazon Web Services. Why had Amazon Web Services this kind of success? Well, I'm in the hosting business for, I don't know, 5 or 7 years now, and attending conferences. I've seen, let's say, the whole domain evolving towards the cloud. I know a few years ago, I attended a conference called the World Hosting Days. There was a guy from Intel on stage, and he talked about their new processors, and they had this virtualization support built into the processor. So until then, I thought maybe this is just a buzz. Maybe, this whole virtualization thing is just the new black, and it's going to fade away just like fashions usually do, because IT is a fashion-based industry. You all know that. But the virtualization thing has real meaning for companies, which means looking at a data center a few years ago, we had a lot of spare capacity. There were servers in the data center consuming a lot of energy, producing heat that requires cooling, that then eats a lot of energy. So the idea was to consolidate those spare capacity and save money by getting rid of servers you don't need. So now think of a large company with a big industry, building an infrastructure that copes with heavy loads, such as Amazon did. And I think it's one thing to build such an infrastructure, and it's another thing to really recognize that there's a technology that can be useful for many other companies too. So they shared their infrastructure, and they gave access to those, new features. And along with the pay-as-you-go model, we are talking about the cloud as I perceived it. In terms of infrastructure as a service, you're getting virtual machines, and you pay them as you go. So we're talking about European cloud. So why don't we share globally? Why don't we have, the single cloud? Amazon, for example. The answer to that is somehow related to the latest news. I mean, I don't want to go into that too much, but we have learned that we have to take care about privacy. I think this is a very complicated topic, and we are on a dev conference, so how much do we have to know about privacy? How much do we have to care about privacy? I would like to start and just give you a rough idea about how privacy or what privacy issues are actually out there, because I wasn't aware of that a long time. It's a basic fact of European privacy law that no company is allowed to pass data of European citizen to another non-EU country in case this country does not guarantee a privacy level compared to the EU. It's prohibited. And this is the case for the US too. So basically speaking, per default, it is not allowed to pass your data to a US company. This is true for software as a service, this is true for platform as a service, this is true for infrastructure as a service. So this is where safe harbor comes in. And I think we all have heard about this word many times. So what is it? Not going too much into detail, safe harbor is actually an EU directive, which means that the European Union somehow decides something that the countries of the European Union should care about, and they require them to care about that, but they don't know how exactly this needs to be done. So there's still a room for interpretation, still room how to implement it. But they say, you have to care about it. And it regulates the processing of personal data within the EU. Then we have the US-EU safe harbor thing. Well, it sounds really, really good, but in the end, it's a process where a US company can do a self-certification and thereby swear to the United States Department of Commerce to comply to EU privacy laws. I mean, self-certification doesn't sound like there's, an enforcing party taking care of whether this is really the case, but I'm pretty sure the large companies, they do care and they do, let's say, comply to a degree to the EU privacy laws, which means that they might not walk around and sell your data to arbitrary third parties. So I think for this, it is good enough. But there are people thinking that safe harbor might not be that safe. So I'm talking about a memo from the European Commission itself, and they are very careful with this kind of political statements. But they say that the safe harbor agreement might not be safe after all. There are investigations ongoing to really check that, but I don't think that there's much effort required to see that safe harbor is actually about marketing. Which leads us to the term we all heard too, the Patriot Act, which stands for, this very long term. I don't want to read it. Pretty sure you don't care. It's just to have it on slides. Sounds good. The Patriot actually is a United States federal law, which means that the government is allowed to significantly enhance things like electronic surveillance, and this obviously has certain impact on safe harbor. So the Patriot Act itself is a very, let's say, it's not something you can just, put into one term. So we have those 10 titles. I will not go through them, but just to have an imagination about the size of this thing. What we have to know in the context of this discussion is that the Patriot Act beats safe harbor. When it goes to national security, there's no compliance to the EU privacy law of interest, but the national security. So it's always the same. When it's about security, and consider you are a government, and you have to ensure the security of your citizen, how far do you go? I mean, that's the question of the latest, NSA and PRISM thing. It's not about saying that all those things are bad, but it's about asking the question, how far do we want to go? How much freedom do we want to give up to be secure? And to give you a rough example on how this Patriot Act and safe harbor thing, especially in this case it's a Patriot Act thing, can actually impact your company maybe. There's a story of a company called Lavabit that was really somehow making me uncomfortable, because until then I thought, well, I'm not a terrorist, I'm not a bad person, so why do I care? And the story of LavaBit, which is about a company offering encrypted email services founded in 2004 by a guy called Leveson, tells that he is not a terrorist, he is not a bad person, but he offered a service with its unique selling proposition being secure, being a secure email service. Well, this guy offered a service, and another guy called Edward Snowden, I'm pretty sure you know this guy, used his service. So now somebody else does something that becomes interesting for the government because of national security issues. So this Leveson guy was ordered to turn over its SSL privacy key, actually giving up the major point of his service. So in short term, Leveson was put to the decision, either shut down the service or become complicit in crimes against the American people. So LavaBit was shut down. I think that's impact. That's real impact on somebody's life who built business and then just had to give it up. I don't want to argue about the reasons or whether this is good or right. It's just about noticing that there are things going on that somehow have impact on what we do. And as I said, privacy is about, or security is a question that impacts our freedom. And I think we have to draw a line to say, well, this is worth it and this is not worth it. This is a quotation from Leveson. He said, "This experience has taught me one very important lesson. Without congressional action, a strong judicial precedent, I would strongly recommend against anyone trusting their private data to a company with physical ties to the United States." I think this is a strong statement from somebody living in the US. I'm not here to tell you don't put your data on US infrastructure, because there are a lot of good US services out there, and I really love those services, and I love to use them. But there are also customers out there, your customers, and they have maybe, especially due to the latest news, an opinion about privacy. So the question is, which of your applications can you put on US infrastructures without messing up with your customers' expectations? So I've spoken to many companies, and they were saying, well, who cares about data privacy? My customers don't. And there was another guy in the room, and I said, it seemed like cheating your girlfriend. She doesn't care until she knows. So do your customers know, in case you're on US infrastructure, that you pass on data outside of the EU, being unable to protect the data? And I'm sure that there are cases where customers say, well, that's okay for me. But there are also cases where customer might not want this. And this is what the discussion is about. People should have a choice. That's why we have to accept that it's not only about having data on European servers. It's not only about having a company that complies to EU privacy laws. And it's not only about having a European company to be decoupled from this Patriot Act issue. To really be safe, it would require to be completely off any US provider and don't tie to the US in person or with your company. Well, this wouldn't make the world a better place. But this would allow you to, let's say, resist a call for opening your service, at least for foreign security service. You still have to struggle with security service from your own country, sure. But from what I've heard, they are less obtrusive than other ones. Another tip is to rely on open source software, as this gives you more transparency. You can have a look at the software stack you're using and have an imagination about whether there's a backdoor in it or not. It's not a 100% guarantee. I mean, we all know that there are also rumors about hardware for example, generating random numbers that could be compromised. But it's definitely better to have an open source stack in place where you have at least a chance to recognize backdoors and fix them in case you find them. So, summing this up, we have to learn that privacy is something we have to deal with. We have to draw a line for us as a country, for us as a company, for us as Europeans, and answer the questions, how far do we want to go to ensure security? So, personally, and this is only my decision, I don't want to put sensible data or sensitive data on US platforms. And I use US platforms for things that are good. So, my personal opinion is that we need a European cloud, which leads to the question, how to build it. So, building clouds means to have a rough idea about what a cloud is, and as I already mentioned, and you already know, there is no roll-up at a conference that doesn't, contain the word cloud. A good conference to watch this is the World Hosting Days in Germany, one of the largest hosting conferences. There are very few companies really having cloud technologies, but everybody has it on its advertisement. So what is this term actually about? And we go along with this definition that will do the trick for this talk. Cloud, for me, is infrastructure as a service, platform as a service, and software as a service. So what does it mean? Infrastructure gives you virtual machines, networking, and decouples from bare metal servers, where platform as a service gives you means to deploy applications and bind services so that you actually don't have to care about servers at all. So where infrastructure as a service requires DevOps skills, platform as a service users, they don't have to have, in-depth skills. We talk about those no-ops profile. And of course, software as a service. Software as a service usually gives you added value software like a business process as a service, and you can, as a user, maybe have a billing system or something like that. So these three terms build up what I consider to be a cloud, which means you got the infrastructure that is scalable, robust, and maybe self-healing. You got a platform that allows you to bring those features to the application and service level, and then you provide added value services to your customers. The rest of the talk, we are going to talk about infrastructure as a service and platform as a service, as the talk is called Building a European Cloud with Cloud Foundry. And Cloud Foundry is a platform as a service. So how could we do that? And here it comes, a 2013 proposal for open source based cloud. There are several ways to do it, and in the following I'm going to present an opinionated stack. So we are going to have a look at OpenStack and Cloud Foundry. OpenStack is a technology that is pretty interesting. HP is offering a public version of it, and Cloud Foundry is a platform as a service. There are others, such as the OpenShift of Red Hat, and of course you are free. That's the choice. The choice is up to you. It's just a proposal on how this could look like. So basically what we need is a hardware layer. So even if you're in the cloud, somebody has to run servers. Otherwise, there's no cloud. Then you build infrastructure as a service on top, which deals with the hardware layer offers servers, network, and storage to the infrastructure as a service, where the infrastructure as a service helps you to spin up virtual machines and is the foundation of platform as a service, which takes virtual machines and slice it up even further, offering an API and services. So concrete, this could look like this. You have hardware, you put OpenStack on top, which gives you a kind of Amazon Web Services based on open source software. You can have Cloud Foundry on top, and then deploy your applications. What you gain from that? You can build applications against open source technology, and Cloud Foundry also abstracts from the infrastructure layer. So the suggestion of mine would be to use OpenStack, but you could also take your Cloud Foundry and put it on Amazon. No problem with that. And you're building your application, your software as a service, against a no-vendor lock-in technology that can be easily transferred somewhere else. So let's dig a little bit deeper and have a look at OpenStack. I'm pretty sure the HP guys have more in-depth knowledge than I do, but you should have a rough imagination. I hope you can see that. It's very hard to find a diagram that shows the architecture of OpenStack, but there are three major components. The compute part is actually the part that spins up VMs. The networking part that allows you to create security groups and private networks within virtual machines or between virtual machines, as well as storage. So let's have a look at the components that are making up the OpenStack system. First of all, there's an identity manager called Keystone that's responsible for authentication, policy management, and offering a service catalog. There's Nova, which offers the actual creation of virtual machines and management of virtual machines. There's Clans, which is a service to create and manage virtual machine images. So, for example, you can use Amazon AMIs here. Then there's a component called Cinder, which is about offering block storage. So you're creating a virtual machine. You want to have a persistent disk that won't go away in case your virtual machine goes down. So you want to have storage on a block device, similar to Amazon EBS volumes. And this is what Cinder does. Like offering or deploying an application usually requires storing file uploads somewhere, so you need an Amazon S3 replacement, which comes with Swift. And this guy also scales to petabytes sizes, so it's very, very nice. And the networking layer, Neutron. So it's about building security groups and stuff like this. Okay, to put it in simple words, OpenStack provides us an infrastructure as a service layer that's good enough to deploy a platform as a service layer on top. And that's what we need to build our platform as a service cloud. So now we're ready to talk about Cloud Foundry. A few words about it. Cloud Foundry itself can be considered as an open source Heroku. Pretty similar architectural approach. There are slight difference in the architecture though, but it's for a mental model, it's good enough. It itself is a large distributed system, which means you have, let's say, a dozen of services you have to run. That's why Cloud Foundry is separated into two different terms. That's the inner shell and the outer shell. The inner shell is referred to the actual Cloud Foundry system. So what you perceive when interacting, uploading applications, and binding service and stuff like this. As well as the outer shell, which is the number of system components that make up the platform as a service. Cloud Foundry comes with a tool that is about deploying Cloud Foundry. So there's a tool that allows you to abstract from the infrastructure as a service layer, having an abstraction for accessing AWS or OpenStack or VMware, for example. So with Bosh, you can easily deploy Cloud Foundry on AWS, on OpenStack, or VMware without having to change the actual Cloud Foundry. To have a look at Cloud Foundry architecture, I put up a diagram that a little bit oversimplifies the thing, but it's good enough to have a first idea about how a platform as a service looks like from the inside. So first of all, there's a cloud controller. This is a Ruby application that offers the API endpoint. So whenever you do a CF push to push your application, to deploy your application, or a scale to scale your application, you're talking to the cloud controller. Beside of offering the API endpoint, the cloud controller's job also is to be the authority of creating, commands that really change the state of the system, such as starting apps or creating services. A platform as a service also deals with the problem or the challenge of distributing your application across several physical or virtual servers. So what you have is a component that's called a droplet execution agent. This is basically your application server. Of course, there are more than one of them. And the terminology in Cloud Foundry is that a DEA, which stands for Droplet Execution Agent, is a component that executes droplets. What is a droplet? When deploying your application, let's say a Rails application, you have a number of files that contains your application code, but it's not enough to run on an application server, because in the past, you want to remain independent from technologies. So let's consider a Rails application to be a triangle, and the DEA is only capable of executing squares. So how to make the triangle become a square? What you have to add is the language dependency, maybe a web server or something, and this process is called staging. So taking the application code and put it into something that can be executed on a DEA. This process is called staging, and the end is called a tar archive that contains this package that can be executed. It's called a droplet. The DEA, as every platform as a service, also contains a framework for isolating one application from another. So your application could be on the same server than the application of another company. So the isolation between one application to the other, along with the assurance that your application don't eat up more memory than it should, is done using operating system virtualization, where Heroku did this with LXC. Cloud Foundry is using Warden, and Warden is not itself a virtualization technology. It's more like a framework. So you can have a Warden for Linux, which use C groups, for example, and you can also have a Warden for Windows, which some companies already did. So they're providers, and you can throw Cloud Foundry Windows apps at, and they will execute it. So in the end, the idea of DAs is to start and run droplets. Now, what happens if a server goes down and let's say hundreds of droplets are dying? Well, there's a component called a health manager that continuously reads the desired system state and compares it to the actual system state. So if your application is intended to have 10 instances and the health manager only finds 5 of them, he talks to the CC and says, well, boss, please, there are 5 missing, spin them up. And the CC does it. So your applications will be started somewhere else. DAs will take responsibility and spin up your 5 applications, so you'll be good. So that's how a platform as a service can actually cope with outages of DAs very easily, and there's only very little impact on your application. Now, having this in mind, that a server can go away or application instances could die and they will come up somewhere else, somebody has to know where your application instances are at the moment. As Cloud Foundry becomes a very dynamic environment where your applications can show up here and there, and this might change very quickly, this is clearly out of range of a regular load balancer. That's why a platform as a service needs a router. There's a new router written in Go. It's pretty cool, supports WebSockets and stuff. So I'm pretty positive that this guy does its job, which is knowing where your application instances is and routing incoming requests to the appropriate DEAs. And of course, you can bind services to your applications. You can create databases such as MySQL, Redis, or whatever. So creating a service means to provision a service. Binding a service means to create credentials, and credentials are injected into your application using environment variables. This is pretty similar to Heroku, and it's also compliant to this 12-factor manifest Heroku came up with. So in the end, what do you get? A similar experience than Heroku, which is shown in this small screencast, just demonstrating the user experience with the Cloud Foundry system. So it's nothing you have to follow, line by line. It's just showing you, giving a visual impression about how a Cloud Foundry system looks in the end. And that's it. Thank you very much. If you have questions, you're welcome. We also have a booth downstairs, so if you want to have a more detailed chat, you're always welcome. But taking questions now. Yes?
So we use Amazon Web Services quite extensively, and we've been looking at Google Compute Engine and some other alternatives. And it seems like the biggest issue for us is actually not the platform as a service or the infrastructure as a service items are what they usually refer to, because we have the ops skills and we know how to run this stuff. The issue is that Amazon's the only one who provides things like managed databases, like DynamoDB. They have a really good queue system called SQS. How do you view over customers who need this sort of managed data store? So not S3, not EBS, but something like DynamoDB.
Yeah, that's a good point. So when I got your question right, the question is, how can you guarantee that there are good services despite of the...
Sorry, I did a bad job asking the question. Sorry. So the question is, we need a key value store that can scale to ridiculously large amounts of data that we don't have to manage.
Yeah.
And Amazon gives us that.
That's what I refer to as a service. So
okay.
Like in the 12-factor manifest, they are called backed services. So your app relies on something like a key value store. So who's offering this key value store? Well, building your own platform as a service also means you have to pick services you want to offer, and you have to implement and keep them running. So currently we have 5 services, and we will add more services in the future. It's also a question whether we want a marketplace so that companies can say, well, I'm pretty good in Elasticsearch. I will offer Elasticsearch cluster. How can we do that? So yes, you're right. Like managing services is an issue, and the answer to that is we need like DevOps that will take care of a certain service and run it and offer it on a platform as a service. And we are adding new services right after getting out of beta. But yes, this is interesting. Anybody else? Well, then thank you very much.
Thank you, Julian.